All right, so we still looking at transformations, but specifically, we're going to be looking at enlargements right now. Okay, we're going to be looking at enlargements. So the first thing we want to look at is how to calculate the center of enlargement. Okay, so in order to calculate the center of enlargement, corresponding points must be connected with a straight line. So where these lines intersect is the center of enlargement. All right, so for this one, I want us to calculate the center of enlargement. So I'll show you guys how we go about doing this. This is what we have now, ladies and gentlemen. We have object and we have its image. Okay, now when we are trying to find the center of enlargement, what we do is we would draw a straight line. So because of that, I'll actually use a straight line. So what we need to do is connect corresponding points and follow through. When I say follow through, I don't mean to draw from here, then stop here. Okay? We don't stop here, we continue. So for instance, if I'm going from B to the next B, I just follow through. I just keep going for a little bit and don't stop. Okay, all right, so that's my first one. Next thing, we do it again. So now we have to do the corresponding point C and pass through C. And as I said, we just follow through. We just go straight through, following through. Yep. And as you can see here with the follow through, look where it crossed. Okay, they cross at a similar point. Now, just for good measure, we do it again, this time with A passing through A. Okay, and we follow through. Notice I didn't stop at A. I kept going, straight line. Now, the important thing is where they intersect forms my center of enlargement. So right here would be my center of enlargement. So what is my center of enlargement therefore? 0, 0. Okay, so my center of enlargement is the origin. Does that make sense, guys?
Yeah.
No, it doesn't have to be the origin. In this case, it is the origin just by chance, right? But it does not have to be the origin. So you see, I connect the corresponding point. So B went with B. You see? Does that make sense? All we doing is drawing lines. Nothing outside of the box. You understand? I ain't asking you to calculate nothing. All I want you to do is draw a line from this point to this point and extend that line. Does that make sense? So where you think this point is gonna go to? Let's do that again. We starting again. You got to get this. Okay? Because it's easy marks. So B prime goes through where? B. Good. And we extend that line straight through. Why we said straight through? Because at some point it needs to cross. Next one, C prime. This is the corresponding point for this. This is a positive enlargement. Everything is the same direction, blah, 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 what's not. So now we go C prime straight through where? Where is it going to go through this time?
C.
Good. It's going to go through C. So we go C prime straight through C and we extend. We continue to extend. All right. What's the next line we want to do now? A prime straight through where? Go straight through A. You see? But look where they all intersect. You see where they intersect? Good. Next diagram. So that means there's where they intersect 0, 0. So 0, 0 is the center enlargement. Next diagram. Looking at this one, I want y'all to try on your screen. So maybe you could screenshot it and then try to draw on it to see if you could come up with the center of enlargement. Okay? Then what we're going to do is we're going to go through it together. So for this one, if you look at this, the corresponding point for this is located where? Tell me the coordinates of the point that is corresponding to this.
3, 4.
Good. 3, 4. Okay? So 3, 4. All right? So then I would come here, connect it with this, and just continue drawing. Just continue drawing. Did what I do just now make sense?
Yes.
Lovely. Good. Now, next thing we do now, we have to do another corresponding point. So what is this corresponding point for this guy right here? 5, 7. Yeah? So the corresponding point for this is 5, 7, which is right here. So then what we would do is come here, pass through the top of this one, and we continue, okay? Boom. Now what about this one? Where would the corresponding point be for this guy here? 7, 4. Excellent, 7, 4. So right here, we go through here, and we connect. All right. Now, if you look at this, the scale factor of enlargement is what? This is 2 from the base. What about this one? This is how much on the base? How big? 4. Good. Okay. So we got 2 here and then 4 here. All right. Now, if you have 2 here and you have 4 here, That means it's double. It's double the size. Because to get from here to this size, you double it. Now, all these lines that we connected to the corresponding points connect to this point right here, all right, which is 1 and 0. So then 1, 0. So right here is 1, 0. So this here is the center of enlargement, okay? So the center enlargement for this here is 1, 0, okay? Anybody got that? And they, when they tried it? Right, so 1, 0. So these corresponding points, they go here to here, and the B connect to that, C connects to that. So then we have 1, 0. So that's the center of enlargement. Okay? Okay. Which points are we connecting to each other? The same points, the corresponding points. So look at this. Tell me the points on this shape here. What are the points on this shape object?
ABC.
A, B, C. Do you realize that the corresponding points for this is here, just bigger?
Mm-hmm.
That's why we call it an enlargement. So if this is the top of the triangle, this is also what? The top of the triangle. If here is the top of the triangle, here should also be the top of the triangle too. If this is the right of the triangle, what this here represents? If this is the left of the triangle, what is this? So we are connecting like for like. You following me? So then that's going to pass through here. Does that make sense? And this one, where is this one going to pass through?
B.
Now we are talking. And what about this next one? Good. See how easy that is? And then now that means my center of enlargement is what? 1, 0. Lovely. So this is how we deal with positive enlargements. So I want you to answer that now on your paper and send them to me. So I want you guys to look at this one. So the first one I want y'all to try is this here. Okay? Just try one for now to try to find the center of enlargement. Let's see what y'all get. So you can do it on your tablet. You can do it on by printing it and just send it to me. So do this one, this one, this one, and this one. And then after we move on to the next part, which would be the negative enlargement form of it. Alright, so guys, check this out now. So the first one here, just to reinforce, connecting the corresponding points. So this is a triangle here. This is the top of the triangle. This is also the top of the triangle. So I'm running my line straight through those. Okay? And I do a little extension just because I need to make sure that whenever I draw all of them, they intersect somewhere. So I'm gonna use this one here now, different color. So let's say from here now, this is the left of the triangle. Here's also the left of the triangle. So I connect those 2 points and extend. If you notice, I intersect at a particular point. Now I'm going to use a different color. This is just for you all to see how it works. So here now, it goes from here to the tip here as well too. So from this piece here, straight through to this piece, which passes along here. Now if you look at this, you can see now that they intersect at this point, which is -4, 2. So right here is our center of enlargement. Now, likewise, for this one here, I need to connect the corresponding points. So, in this case, since it's a regular one, so this top of the triangle, the top right corner, I'm going to connect it to the top right corner here. So we're going to go like this, and I extend. I'm just extending. There's no right way or wrong way to stop. But if I don't extend, it's not going to allow me to have that intersection. So then now what I could do is do a next line. So now I'm doing the bottom right corner for both rectangles. So look at that. See? Boom. Where they intersect. So that's already showing me where it should go. So then now, from here now, the top left hand corner, we extend. Boom. Likewise, same thing here. The bottom left hand corner, we extend. Boom. They intersect at 4, -1. So my center of enlargement is 4, -1. Does that make sense? You kind of understand now, right? So then here is -4, 2. All right. And here is 4, -1. So 4 on the x-axis, -1 on the y. All right. Good. So this one here, by this time when we did this, y'all would notice that you don't have to necessarily draw every single point, but it kind of helps for confirmation and confidence. So if we have this top right hand corner, we connect it to this top right hand corner and we just extend. So we do that again for this one. So here extend. So this is the bottom right corner, we extend. Same thing here. I'll do it for the top left corner and pass through this top left corner right here. As you can see, they all cross at this point. So the thing is now is that right here, negative 5 is my center of enlargement. Okay, so that makes it easy for me, as you can see here. So then on this part now, we do the same thing. So this point corresponds to this point. So we go from here straight through, okay, then from here straight to this corner, okay, and then we could do from here straight to this corner. See, we pass straight to them points. So then now I could see that my center of enlargement here would be 1, 0. All right, a little clearer now, right? So now we did this. Now we have to talk about negative enlargements. So if you look at this, what do you notice about these two shapes here?
They're both trapezoids.
All right, correct. What else?
One big, one small.
One big, one small, which is a key sign of enlargement. There's something else that I want you to notice. What do you notice about it? About it. I don't want to say it. So if you look at this, right? I want you to look at the shape, right? Then look at the shape here, right? Looking at how they look compared to each other, okay? Now, what do you notice about this? Okay, so let me tell you all. Do you guys notice, right, that in the previous ones, they were the same orientation, even though they were different in size? One was small, one was big. When you look at this one here, what you notice, one is upside down compared to the next. They've rotated opposite to each other. Can you see that? Right, so it's like one is upside down relative to the other. So for instance, this here would be A, B, C, and D, okay? So now if I flip this upside down and rotate it like, and then it enlarge, which is basically what happens with a negative enlargement, what do you think this point would represent relative to this? This would be A, good. What do you think here would be?
B.
B. Here would be?
C.
And here would be? Good. Now, I want you to just tilt your head so you have A, B, C, D. I want you to look upside down. And if you look upside down, going around clockwise, it should still tell you A, B, C, D, just with an apostrophe. Can you guys see that? Good. Now, the thing is, like we did for the last one, now that we know that they are flipped, what we have to do is connect the corresponding points still. So A still has to go to A. B still has to go to who? Lovely. C has to go to?
C.
Lovely. D has to go to?
D.
And what you'll notice is that they all cross at this point here, which is 2, 5. Can y'all see that? So notice the difference between negative enlargement and the one that we did before, which was a positive one, where both of them are on the same side relative to the center of enlargement. Whereas for the negative enlargement, it's in the center, okay? It ends up being in the center. And because it's rotated, remember we have to connect the corresponding points. So A to A, B to B, and so forth. All right? Let's try the next one. Now, if you look at this, what do you notice here again? And by the way, the scale factor of enlargement for this one, see the top of this? This is 4. Top of this is 2. So this is twice the size, but we wouldn't say that it's twice the size. We would say it's negative 2 times the size, right? Because it's a negative enlargement. So if you look at this here now, remember, we're doing the same things here. So if this is A, this is B, this is C, I want y'all to figure out where would be the corresponding A point, okay? Where would be the corresponding C point, and where would be the corresponding B point. So my trick that I like to use to do this, I would look at it from this point of view and go, okay, A, B, C. Then I would look upside down and try it for the other one, okay? So let's see what y'all come up with and then share it with me. All right, so let's go through this now, right? So look at this, A, B, C. Okay, did you guys get this labels correctly? So likewise, we connect A. So just how you look at this, A, B, C, all you gotta do is look at this upside down, and it will be like A, B, C. So literally turn the screen and look upside down, you'll notice it's A, B, C. So the bottom is B of this here, so therefore this here represents B. So then we connect the lines, A to A, B to B, C to C. And look where they cross at 3, 2. So our center of enlargement is 3, 2. All right. Now, So remember to label it like how I told you guys. Literally, if you label this A, B, C, D, turn the paper upside down and do the same thing with here. Okay? So then you get the corresponding points. Literally turn it upside down. So A, B, C, D. If I turn this upside down, turn it upside down with me, I'll have A, B, C, D. Alright? So check that out and let's see how y'all handle the first one. Alright, so let's try this now. I'll do the first one for you guys. So let's say here's A. Let's say here's B, C, D. If I was to go upside down, here would be A, this would be B, this would be C, this would be D. So all I would have to do is make the following connections. So A goes to A, B goes to B, and then with this, D goes to D, and then C goes to C. So they got end up being on the same line. So right now they all intersect at right here. Okay. So if you notice too, all I needed to do was crisscross the first two. So I just need to connect A to this end and B to this end, and my problem was done. You know. Likewise with this one here, all I need to do is connect from here to this other end and here to this end, and I should get my answer. Okay, so it's literally like doing a crisscross. All right, just to make it easier for you guys. So this end goes with the outer end. This here goes with the inner end. Same thing here, outer to outer, inner to inner, outer to outer, inner to inner, outer to outer, inner to inner. So it's gonna cross right here. All right, so outer to outer, inner to inner. All right, so I want y'all try that. So just make sure the corresponding sides here, outer to outer, inner to inner. See what you get. Let's look at this part now. It says calculating the scale factor of enlargement. So when I look at this, how much units across can we say this is here? How much units? Hello? How much boxes? From here to here?
Oh, three.
Three. Good. How many boxes from here to here?
Six.
So what is the size of this relative to this?
Size.
So that's a scale factor of enlargement. Okay? So the size of one side of image divided by the size of the corresponding side of object. So we had here from here to here, it's 6. So the image is 6. That's the size of one side. And then the image and the object, the size of the object is 3. So 6 divided by 3 gives us 2. Okay? So that's a scale factor of enlargement. Does that make sense? Anyone has any questions? You guys understand this? Like, you understand what's going on here? How I got the scale factor of enlargement? Okay, so say for instance, from here to here is how many units?
Six.
And how about here? Right, so 6 divided by 3 gives me what? 2. So I could say that our image is double the object. You see what I'm saying? So that's how I could say the scale factor for this is double. And that's because if I'm looking at this here, because both of them are on the same side of the center of enlargement, same orientation, I know it's a positive one. So I know it's a scale factor is positive. So scale factor here is positive 2. Does that make sense? All right, so I want y'all to assess this and tell me what's a scale factor of enlargement here. All right, so what's its scale factor? 2. Excellent. How did you know it was 2?
Because the object is 2 and then the image is 4. 2 times 2 is 4.
Lovely. That's good. So you compare the object to the image, you realize that the image is double this. All right, so looking at this one, I want you guys to assess this one. Okay, so if you look at this, 1, 2, 3 boxes. And then this got 1 box. So it's 3 times the size. You got it now? You follow?
Yeah.
Likewise, you could do it the other way around. So here is 1, 2 boxes, right?
Yeah.
And then down this side is 1, 2, 3, 4, 5, 6 boxes. So 6 divided by 2 gives me 3. All right, so assess this one and let me know. Okay, but notice, guys, okay, remember what we said our formula is the size of one side of the image divided by the size of the corresponding side of object. So image length divided by object, image divided by object. So when we did this, it was image divided by object. So 4 divided by 2, which is 2. Here was image divided by object. So 6 divided by 3, which is 2. Then here was image. So we did 6 across here divided by 2, which is 3. Image divided by object. Now I want y'all to look at this one. All right, so tell me what you guys got. Image divided by object. Image divided by object. So we have 3 divided by 6, which is a half. Okay. Now we have here a negative enlargement. And once we have a negative enlargement, what that means is when we do find the size, we add a negative number to it. So I want you guys to look at this and then tell me what would be the scale factor of enlargement for this one. So in this case, it would be -2 because image is 1, 2, 3, 4, 5, 6, 7, 8 boxes here. So 8 boxes here. 1, 2, 3, 4. So 8 divided by 4 is 2. However, because this is flipped, this is a negative enlargement. So we say that this here is a scale factor of -2. All right. This one, same concept. Negative enlargement we have here. Who could tell me what the scale factor of enlargement would be? So image divided by object. So 2 divided by 1 is 2. But since this is negative, we would say -2. Okay. Now, let me show you all how to draw these. Okay, so we need to know how to draw these, right? Essentially, that is one of the skills you need to know.